In this part of the lecture, we will be taking a look at the quality of process discovery. More specifically, we will be looking at the different quality criteria that can be used to assess the quality of discovered process models, as well as the differences in models that are going to be produced based on the different algorithms that can be used. In general, the quality of a process model returned by an automated process discovery algorithm can be measured along 4 quality dimensions. 1. Fitness. The discovered model should allow for the behavior seen in the event log, and a model has perfect fitness if all traces in the log can be replayed from the beginning to the end. 2. Precision. The discovered model should not allow for behavior completely unrelated to what was seen in the event log, and here we want to avoid underfitting. 3. Generalization. The discovered model should generalize the example behavior seen in the event log, and here we want to avoid overfitting. And 4. Simplicity. The discovered model should be as simple as possible in terms of the structure of the model as well as the size of the model. So let's take some examples of how those competing quality measures can actually be broken. First of all, a flower model, and this is going to be an underfitting model. And why is it underfitting? Well, it has all the activities that we have in our example event log below. However, those activities can be repeated multiple times and in any order. It is going to, of course, fit all the traces in our event log, but it's also going to fit a lot more behavior than what we actually want to have in our model. Another example would be, or another extreme would be overfitting. For the same event log, we could simply enumerate the traces that we have and repeat them indefinitely. And this is an example of overfitting because it fits all the traces in the event log precisely. However, it also is very restrictive and it can't account for any additional behavior that might actually belong to the given process. So what we actually want is something in the middle, something that looks like this, something that would represent the event log in a good compact way, while still allowing for some behavior that actually is most likely going to be part of the process, but perhaps was not discovered in the original event log or was not recorded in the given data set that we actually have. So process discovery algorithms, they kind of have to strike some trade-offs between those quality dimensions while also avoiding overfitting and underfitting. Here are some examples of different algorithms, such as heuristics miner and Fodena miner. Those algorithms are going to produce high fitness and high precision. A model discovered with the heuristics miner might look something like this. It has some gateways in there, it has some choice points, it kind of shows you the structure of the process, but it still allows for behavior that perhaps isn't seen in the actual event log or might not belong to the process. Then another type of algorithms might be inductive miner and evolutionary tree miner. Those are also going to have high fitness, however, they will have lower complexity. A process model discovered with inductive miner might look like this. It is going to be structured by construction based on process trees, and it actually often falls into the trap of low precision. Here we can, for example, see 3 or 2 distinct blocks, depending on the way you want to treat it. And in the first block, A, B, C, D, E can be executed as many times as we want. Of course, that block can be skipped as well. In the next block, F, G, H, I can be executed, or one of those can be executed. And then finally, J will be executed. Now, this is nice in a sense that it groups the activities together nicely. However, it still allows for behavior that quite certainly doesn't belong into the process itself. And now I'm going to get to the process mining algorithm that we will be discussing in the next part of the lecture, and that is split miner. What it does, it produces process models that have medium to high fitness, medium to high precision, and low complexity. So a model that looks something like this. Here we compare to the previous one, we can see that the first block, A, B, E, D, C, and so on, is going to be, it's more structured. You can clearly see the choice points in there, and it is more fitting to the process at hand. Meanwhile, the second block remains pretty much the same, and the process model ends with the activity J. And in the next part of the lecture, I will go more into details on how the split miner works.